Okay, so surprise, I'm still not here and I won't be all week. So, I'm fine. Obviously, I feel fine. But gotta be home with my kiddos and deal with all of that. So I will be returning to school next Monday, which means everything this week is going to be recorded. But we're going to just keep on rolling as if I was in class. You just need to bring your headphones. I know some of you are concerned about the bonus opportunity. You will still be able to bring your cans. You just will have to bring them when we return to school, or when I return to school. Let me check the dates on that real quick. They are due to me on the 11th. So I return to school on the 7th, so you need to bring them the 7th, 8th, 9th, or 10th. Okay, so mark your calendar, set a reminder, make sure you have your cans ready to turn in to me then. Okay, so like I said, we're going to just keep rocking and rolling. So I'm going to minimize me and pull up our thing, and we're going to go. I'm very blessed that Bird let me bring home my Elmo, so I'm able to teach you guys from home. Super thankful for that. Okay, so today's lesson is in our Springboard book. We are on page 132. Remember that you can pause this video at any time if you need to. Alright, lesson 8.3 is what we are working on. And our learning targets are to factor quadratic expressions using complex conjugates. And remember that a complex conjugate is A plus BI and A minus BI. So remember, the only thing that's going to be different about these two things is one has a plus sign joining them and the other has a minus sign. Then after that, we are going to solve quadratic equation with complex roots by factoring. Remember that complex roots or complex numbers, any of that is dealing with an imaginary number. So we're still dealing with our imaginary numbers, which is the result of a negative underneath the radical. So if we have a -1 underneath the radical, it is an I. And you can always remember my cute shirt that says I heart math. Okay, so the -1 under there is our I. Okay, so we're going to jump straight down here to number 2. It says you can use complex conjugates to factor quadratic expressions that can be written in the form a squared plus b squared. So that means the first term has to be a perfect square and the second term has to be a perfect square. In other words, you can use the complex conjugates to factor the sum of two squares. So both of them are perfect squares. Remember that your perfect squares are 4, 9, 16, 25, 36, 49. Those are your perfect squares. So that's what we're looking for, those numbers. And it has to be a sum. Those are the two things that we're looking for to be able to do this. So if you look at example A, 16 is a perfect square, x squared is a perfect square, and 25 is a perfect square. So what we're going to do is we're going to take the square root of each one. The square root of 16i, okay, sorry, I had to put my kid to sleep. Okay, so you take the square root of 16x squared, which is going to be 4x, because it's a perfect square, and the square root of 25 is 5. Okay, your answer is going to be written as the complex conjugate, which is going to be 4x plus 5, 4x minus 5. The only thing, though, is that does not include the imaginary number. And if I was to do FOIL right now and and work that out. Okay, she's in the bathroom. If I was to work that out and do FOIL, 5 times negative 5 would give me negative 25. Well, I don't want negative 25. I want it to be positive 25. The only way to get that is to add I to each of those. Because now, when we do FOIL, or the box method, which is what we like to do, we've got 4x minus 5i, 4x plus 5i. When we multiply those together, that's going to be 16x squared. This is going to be negative 20xi, positive 20xi, and negative 25i squared, because I times I is I squared. Well, you know I squared is the same thing as negative 1. So negative 1 times negative 25 is positive 25. So first box is 16x squared. Your diagonals cancel. There's nothing there. And the last box became positive 25. So this would be what we get if we multiplied them together, which is exactly what we started with. So when you factor these out, you're going to take the square root of the first, the square root of the last. When you put them as the complex conjugates, you will put the I with that second term. Let's do it again. All right. So 36 is a perfect square, so 36x squared under the radical, and 100y squared. Again, all of that's perfect squares. The square root of 36 is 6. The square root of x squared is x. The square root of 100 is 10. The square root of y squared is y. Okay, so everything broke down. Now I'm going to do my complex conjugates. I've got 6x plus 10y, 6x minus 10y, but I'm adding that I just like that. And that's it. That's how you do it. Okay, if we do it with C, 2 is not a perfect square, and neither is 8. So this method would not work if we simply were just trying to take the perfect squares. What we can do with this one, though, is take out the greatest common factor. The greatest common factor is 2. I'm going to undistribute that. By undistributing that 2, now I have the sum of perfect squares. The square root of x squared is just x. The square root of 4y squared is 2y. So my complex conjugate would be x plus 2y, x minus 2y. And I'm going to add those i's. And last but not least, you've got to remember to put the 2 up front because you undistributed that 2, so you need to make sure you leave that at the very front. And those would be your factors. Okay, we're not actually going to do D, so don't worry about D. Remember, you are turning in your notes to me, so what I'm writing, you should be writing because that's what you're submitting, so you can get credit for today. So that's the first part of that. Okay, so let's go to the next page, on page 133, and we're going to be looking at example A. Now, they show you this using the factoring, which is totally fine and will work, but I'm going to show you a different way. So the first way is the factoring. 9x squared is a perfect square. The square root of 9x squared is 3x. The square root of 16 is 4. Okay, so that's why they have 3x plus 4i, 3x minus 4i, set them equal to 0. Then, just like everything that we did prior to this lesson, you take each parenthesis, set it equal to 0, and then you solve, just like you would in Algebra 1. Okay? Okay, but the other way to do that is when you have two terms and you are missing the bx. Okay, because remember this is a quadratic equation. Ax squared plus bx plus c. So if you're missing that bx term, you can simply solve for x. So I'm going to do that by subtracting 16. 9x squared equals negative 16. Then I'm going to divide by 9. Divide by 9. X squared equals negative 16 divided by 9. Now, I'm going to leave that just like it is. I'm not going to do anything to simplify it. What I'm going to do next is get rid of this square. The only way to get rid of the square is to take the square root. So, I'm going to take the square root of the numerator and the square root of the denominator. The square root of negative 16 is 4i. The square root of 9 is 3. So my answer is going to be x equals plus or minus. Okay, so make sure you put that plus or minus there so that you have both your positive solution and your negative, and then you've got 4i divided by 3. And that's your solution. That's two solutions because you've got the positive and you have the negative, just like the book has over here. They have the negative listed first and then they have the positive. Okay, so either of those ways will work, and I'm going to show you both. Alright, so if we look at B right here, 100x squared is a perfect square. So when I take the square root of 100x squared, that's going to be 10x. The square root of 49 is 7. So my complex conjugate is going to be, I'm going to just use this one, 10x plus 7i, 10x minus 7i, and I'm going to set that equals to 0, because remember, unlike the ones before, this one is equal to 0 because they want us to actually get a solution. Okay, so I'm going to need some more space. You may have to plug yours or shove yours in somewhere else, write a little smaller. What I'm going to do now is I'm going to take each one of these, drop the parentheses, and set it equal to 0. Okay? From there, you're going to just solve just like normal. So I'm going to subtract 7i. 10x equals negative 7i. Divide by 10. X equals negative 7i over 10. That's one of the solutions. Over here, I'm going to add 7i. 10x equals positive 7i. I'm going to divide by 10. X equals 7i divided by 10. So you've got your positive and you've got your negative. Those are your two solutions. Now, the second way that I told you could solve this was simply just by isolating the x. So let me show you the second way. And I'm pretty much going to let you decide how you want to go about doing this. You guys are smart. You're old enough to make your own decisions. So this would be the second way. You subtract 49. 100x squared, that's important, equals negative 49. Divide by 100. X squared equals negative 49 over 100. Again, I'm just leaving that alone because those are perfect squares. I'm going to take the square root of the numerator, the square root of the denominator. So, the square root of negative 49, that's 49. Negative 49 is negative 7. Well, no, not negative 7, is it? It's 7i. Okay, 7i. And then the square root of 100 is 10. So, my answer is x equals, don't forget the plus or minus, because it's both the positive and the negative, 7i over 10. So again, this is two answers. the positive and the negative, and this is two answers, the positive and the negative. So you get the same thing either way. So you just decide which one you think is easier. Do you think it's easier to do the complex conjugate, or do you think it's easier to do the solving? Doesn't matter to me. Okay, let's look at this one. If we look at C, okay, what we're going to do with C right here is I'm going to add 4 back to this side. So that's going to give me 25x squared plus 4 equals 0, because that's the first thing I want to do if I'm going to do the complex conjugate. So both of those are perfect squares, and it's the sum. The square root of 25x squared is 5x. The square root of 4 is 2. So my complex conjugates are going to be 5x plus 2i and 5x minus 2i, and that equals 0. Okay, so from there, I am going to set each of those equal to 0. 5x plus 2i equals 0. 5x minus 2i equals 0. Solve. I'm going to subtract 2i. 5x equals negative 2i. Divide by 5. X equals negative 2i divided by 5. So what do you think that one's going to equal? It's going to be positive. So 5x equals positive 2i divided by 5. So x equals positive 2i divided by 5. So those are your two solutions. Just like that. Easy, easy. Okay. For D over here, if you look at D, you can see that neither of these, well, actually 36 is a perfect square, but 2 is not. So I can't take the square root of both of those. So what I need to do is either divide that 2 out or just solve for x, which is what I'm going to do. So I'm going to subtract 36 on both sides. 2x squared equals negative 36. I'm going to divide by 2. X squared equals, now that's divisible, so I can simplify that. Negative 36 divided by 2 is negative 18. Okay, so unlike the other ones, I simplified because it divides evenly and gives me a good number. So now I just take the square root of negative 18. Now, negative 18 is not a perfect square, so this is where you have to simplify that radical like we learned at some point. I think I was in class. Okay, so you are looking for either a perfect square or you're going to prime factorize. Well, I'm going to use the perfect square because this one's easy. 9 times 2. Okay, so 9 times 2, 9 is a perfect square. The square root of 9 is 3, so it comes out of the radical. And 2 is not, so it stays inside the radical. Now, this one's negative. Okay, so because it's negative, I'm going to have an I right behind that 3. So my answer is going to be x equals plus or minus, because it's both positive and negative, 3i square roots of 2. That's it. Okay, so this is what your lesson is on today. You are solving the complex numbers. Okay, so your lesson so far is about 19 minutes. So you're going to listen to this in class. You're going to take those notes and you're going to submit those notes to me with your homework. This is your homework assignment. Okay, you are doing, I want to make sure I give you problems that have good answers, nothing too crazy. So I want you to do 9 and 10. Both of those have a greatest common factor. By saying that, I mean, like if you look at number 9, those aren't perfect squares. So you have to take out the 3, undistribute the 3. Then you can start the process of doing the square root of each of those. Okay? Same thing with this one. Take out your greatest common factor first. Then you can simplify. Okay? Then I want you to do number 13 and 14. And that's it. Just those 4 problems. Okay? We will check that tomorrow. First thing, it will be recorded. I will not be at school. But do your notes. Do your homework. You should still have somewhere close to 30 minutes left in class if everything's going smoothly. So do those problems and make sure you get that submitted to me on Canvas. If you have any questions, you're more than welcome to email me or send me a message on Remind, and I will get back with you as quickly as possible. Y'all have a great rest of the day. Stay well.